All righty. So if I remember right, we wanted to just kind of go over the two soil health assessments that you had sent in
Correct.
previously.
Yeah, I'll
Okay.
probably either on a separate or tack on to the front of the recording when I get it, maybe a separate one, just kind of an overview of a lot of different kinds of soil assessments or soil testing and stuff, and I guess kind of the history of, where soil testing came from, just a real high level one, just for those who may not be real familiar with it, although I'm sure that several people in the Master Gardeners are much more familiar and knowledgeable about it, but some of us aren't. But in any case, so we had a previous quick conversation about what is this test that I submitted? What is it as opposed to the typical land grant, University of Arkansas type soil test? And also, my interest was in, I had learned about what was called the Haney test, and then what this is as compared to that. So just
Okay.
kind of, and then any specifics you might want to go over on these two particular plots.
Okay. Well, and yeah, I'll just kind of go over the test a little bit first, and then I can share my screen. I downloaded those two results, and so I can put them right up on the screen and
Yeah, I
just
went
talk
through the
through them.
guide and made a whole bunch of notes on mine
Right.
too.
Right. Well, as far as the Haney test goes, we were the first commercial laboratory in the United States to offer the Haney test back in 2012, and we ran it for well, we still can run the Haney test as it is, and as when I get to the end of this, you're going to understand where I'm coming from a little better. But um, and so kind of we ran it. Now there was a man named Lance Gunderson that was the original soil health director here at the lab. And in August of 2019, he left to actually go open his own laboratory. And he had always reviewed all the Haney tests. One thing that makes us at Ward Laboratories unique is every single test result, and that's whether it's soil, plant tissue, water, manure, feed, is all looked at by a professional, by human eyes, before it goes out to the customer to make sure. A lot of times these instruments are in these labs are not perfect. Once in a while they'll kick out a bad number. We can catch those before we send a result out and then rerun something if we need to. So when he left, Dr. Ray Ward, our founder, started reviewing the Haney test. Well, it didn't take him long to see that when pHs on the soil sample went to 7 and above, which honestly in the United States the majority of the soils are above 7. They have a lot of calcium carbonate in them. And when they did that, if we did nutrient recommendations off that, and we had been for 10 years, or well, 7 years at that point, but um, he thought this doesn't line up. And we had what caught his eye first was we had some people sending in Haney tests, and we'd split the sample and then also run regular soil analysis on it using our normal chemical extracts for each, test item, each nutrient. And those extracts have been calibrated by 50 years of land grant university research to a yield response, by adding fertilizer based on the parts per million on the soil test result. Or in a sufficiency level, we know what's low, we know what's medium, and we know what's high,
Mhm.
for phosphorus, potassium, calcium, magnesium, all that. Um, and so when we give nutrient recommendations off a regular soil test, we know those are correct. Um, and so when he started looking at that, there was some of these Haney with the Haney's H3A extract for phosphorus for the micros that they were recommending zinc, for example. Well, on our regular soil test, we had plenty of plant available zinc. We wouldn't recommend any. And there were several things on different nutrients he saw like this over time, and he started thinking this we got to do something different. And so for the soil health assessment, he kicked this around for about 2 years until myself and a couple others convinced him to make the move. So I'll explain this. The Haney test is made up of three individual analyses. The CO2 24-hour soil respiration. We measure CO2 in parts per million given off by the microbes. And The larger that number, the more microbial biomass you have. Then there is the water extractable organic carbon and organic nitrogen. That is the most readily available food source for the microbes that we identified with the CO2 respiration. And then he come up with an H3A extract, which is a mix of malic, oxalic, and citric acids to extract phosphorus through the microbes. Well, the problem is Rick Haney kind of said, this is what it is, but there was never any calibration work done on it. And so, like I said, after seeing the problems we did, we came out with our soil health assessment, which is what you ran, David, on your two samples, and we'll look at here in a few minutes. So we retained the CO2 respiration. We still run the water extractable organic carbon and organic nitrogen. In place of the H3A extract, we run our normal chemical extracts we do on a regular soil analysis. So for phosphorus, our standard is malic 3 extract. We also extract sulfur with that.
Which is the same. Which is the same the University of Arkansas does.
Right.
So anybody going through
right. And for where you're at in the country, malic is the right extract. Anything west of the Continental Divide in the United States, we swap Olson extract in instead of malic for phosphorus, because those soils have a lot of calcium carbon in it. Olson is a good high pH extract. It's better when pHs get up around 8 and in there. And then ammonium acetate for the cations, potassium, calcium, magnesium, sodium. DTPA extract, and I can't even tell you what that all stands for. It's about a 50-letter word. So, but that's the standard everybody uses for micronutrients: zinc, iron, manganese, and copper. And so when we did this, one thing that it gave us was the ability to now report cation or sum of cations, or CEC, cation exchange capacity, and base saturation. We couldn't do that with the H3A extract. And then when a producer asks us for, I'm going to grow corn and I want a 200 bushel yield goal, we know the nutrient recommendations we're going to give him now are correct. Now, where it's similar is to the Haney is on the calculation side. We still give you a organic nitrogen release, which is an extra bonus of a biological test that you don't get on a regular soil test. We also do plant available nitrate and ammonium, and then we add the 3 together when we're figuring up what we need to apply to meet a yield goal. Those are 3 different credits we can take off the starting point of nitrogen. And we also give you the carbon to nitrogen ratio, which is important. We give you the percent microbial active carbon, and I will show you when we start looking at the result why that's important. And then there's a soil health calculation, and that is still calculated the exact same way. And then in addition, there was not a physical measurement was part of the Haney test, and Dr. Ward decided, let's run, and we call it our modified wet aggregate stability measurement. So we will report a percentage of water stable aggregates in that soil sample. And having a high percentage is highly desirable. That's more aggregation in your soil. That can hold more moisture when it rains and not run off. Okay. And so that's an added thing that we threw in, and it's been extremely popular. Everybody likes it. Now, what makes it modified is that we count the larger sand grains, 0.25 millimeter to 2 millimeter in diameter, as an aggregate. In our regular wet aggregate stability that uses a different method, well, it's actually the same method. We just skip a step on the modified. On the regular wet ag stab, if the soil texture is over 50% sand, we can only report sand present, and we won't give you a percentage of water stable aggregates. On the flip side, with the modified, if I have a really sandy soil, and if it's got a cation exchange capacity of 5, that's pretty sandy soil. You're always going to see the percentage of water stable aggregates up in the 90% range, because the majority of that soil is sand, and sand's counted as an aggregate, if that makes sense. Okay. So it's not perfect either, but it is a measurement, and for most soils, it's pretty eye-opening actually for a lot of people. like I said, neither test is perfect, but it's better than doing nothing.
Right.
So anyway, that's basically the soil health assessment, and we've been running it a little over 2 years now. We started in February of 2022, and have run thousands already. And everybody has been that we work with has been switching. We don't
So,
run.
so, so one
Sorry.
good thing would, yeah. So one good thing would be for people who have traditionally just done like at the home garden or community garden standpoint, they've just been sending it into their local extension office or whatever. And that's basically a chemical assay. And it is what it is. It's very standardized. It's very tried and true,
Mm-hmm.
all that kind of stuff. But if somebody wants to move and begin adding in more of a biological aspect to soil testing as opposed to a purely chemical one, then there's the looking through the microscope and starting to count bacteria and fungal fragments and all that, the more the Elaine Ingham version and other things. So this is just for those who may not have heard of either the Haney or this one. If you're wanting to move a little more towards or add in more of a biological assessment, this could be a step in that direction.
Yes. One of the one of the things that the Haney test and also our soil health assessment do, it allows you to track your progress,
Mhm.
and that comes from the calculations. And so if somebody like here, I'll have producers that have been doing no-till for a number of years, but now they're going to start incorporating some cover crops, after the cash crop, keep a living root in the soil more, you know, more throughout the year. Um, I tell them, run this test. We're going to give you the nutrients, so you know what you have for plant available nutrients. But this is your starting point. This is your baseline.
Right.
And that's what the soil health calculation is really made to do. But I will tell you that's not perfect. And I've got an example actually in a presentation that I've done this winter for several groups that I talk about that, because that's calculated using the CO2 respiration, the water extractable organic carbon, and the water extractable organic nitrogen. And maybe I'll hold off on that till I get to percent MAC, and then when I get to showing you on the thing, then I'm going to talk about that a little more, because I need to get you some context first, so you would even understand that. So
That's why I did this soul test as soon as it became apparent that I was going to be kind of the directing force or whatever. At least now is I wanted that baseline, especially like I said in our previous conversation, being a nurse. Somebody new comes into the hospital to the office, you always do baseline blood work and other tests just to you that way you have some idea of,
mm-hmm.
are you helping or hurting with whatever it is you're doing or not doing.
Yeah. So I'm trying to find I'm trying to find my results, and I'm not.
Okay, I've got it.
Okay.
And let's see.
I think I've got, let me get back up large here. I think I've got it. So multiple tests. Okay, there you go. You should be able to share it now. Okay.
Now for there are two plots. There's plot A and plot B. For Karen or whoever watches this later, plot A is the largest one that we're going to be actively gardening this year. It is the one that as you pull in will be on the far right, closest to Riceland Rice and the railroad tracks. That is plot A. Plot B will be the one to your left. The next biggest one, and it's got the between the two trees, and it has the black walnut right next to it on the south side. So that's plot A and that's plot B.
Okay. So anyway, looking at plot A now. When I look at a soil health assessment, I don't necessarily start up in the top left corner. I drop down and I look at the soil respiration. I look at the two biological measurements first. So yes, right there, 30 parts per million. That's not a lot of living biology. We like to see this over 100. The soil respiration, the higher the number, the better. And so a good, healthy microbiome would be probably 150 parts per million and above. And so, you know, but this is for a starting point, and so this is where you're at. I don't know if this plot has had a lot of tiller, rototiller going over it, or tillage in the past. I suspect perhaps it has. Um, but anyway, that's kind of where you're at on the microbial biomass. So then the next thing I look at is the total organic carbon. And so the total organic carbon and organic nitrogen, like I said, are the most readily available food supply for the microbes. So this is 99. Now that's not bad. That's not bad. We like to see it higher, but actually, and this is where I'm going to go down, David. You'll see a little down below calculations, right straight down.
Mm-hmm.
I look then at that microbial active carbon.
Mm-hmm.
What this is, we divide the let's see, it's the CO2 respiration divided by the organic carbon. What this tells me is whether we have enough of the most available food supply, organic carbon being the main one, to feed the microbial population that we indicated with the soil respiration. On this one, we do 30.2%. We don't want to see this number go over 100%, and it can. When it goes over 100%, that tells me that we don't have enough food supply to feed the microbes that we identified. And so what happens at that point? They start looking for other food source, other carbon and nitrogen sources. First thing they go to is organic matter. Now, we don't want them eating into the organic matter because one of the goals of soil health is to, increase your organic matter for a lot of different reasons. Main one being water holding capability, and the other one is nutrient holding capability, because every 1% of organic matter contains 1,000 pounds of nitrogen, roughly, 240, 250 pounds of phosphorus, and about 120 pounds of sulfur. So, and 1% can hold 20,000 gallons of water per acre of, organic matter. And your organic matter is pretty decent, 3.1. That's not too bad. So then I look at the organic carbon to organic nitrogen ratio, that right there. We want to see that between 8 and 15 to 1. This is at 10.6. This is in the sweet spot. I like to see it between 10 and 12. That is in a good shape there. So if you're going to plant some cover crops, half grasses, rye, oats, what have you, half a legume, clover, things like that, field peas, different things as a cover crop, because the legumes will add nitrogen. So you're balanced there, and that's really good. Now, at this point, then I'm going to jump up over here to let's go back up to the top on the left. The pH is 7.1. That's pretty good. I like, for crop production, we like to see pH between 6.3 and 7.0. This is at 7.1. It's fine. Not a problem. There's no reason to do anything, to get concerned and think, okay, how can we lower this and correct it? There's no need to do that with this. Right below that is soluble salts. We don't want to see this over 0.75 millimoles per centimeter. This is at 0.13, so we're very good there. We don't have a salt issue in this soil. And then, like I said, the organic matter 3.1. Now I'll go over to the right under soil tests, and we'll start with phosphorus. And so we identified 75 parts per million of phosphorus using the Malic 3 extract. That is excellent. We have plenty of plant available phosphorus. It's not so high that when phosphorus and potassium get too high, that can be concerning, because that starts interfering with uptake of other nutrients. Zinc is one that phosphorus in a high level will restrict the uptake of zinc. And
what do you consider a high level?
200 parts per million and above.
Okay, because like the other plot is 93. So
yeah, okay.
And for those, and for those who are looking, when he sees the M3, that's the Melic 3. So this middle term here, if I'm understanding correct, is what was used to arrive at the number. That was the testing formula or acid or whatever it's being used, right?
Yeah, right, right. And and honestly, out of these extracts that we're going to go over here, we use for these different things, the malic 3 is the only thing that is a really hard. It's a strong acid. It's got a pH of 2.3, I think Ray told me. Um, everything else, ammonium acetate is a pH of 7, and DTPA is a pH of 7.2. So they're not acidic. So
Okay.
anyway, so we identify plenty of plant available phosphorus. Little, we're not low on potassium, and depending on if we did recommendations on this, and depending on what we're growing, might be plenty. If this was corn production, we would be recommending to add some K2O potassium fertilizer with this level, but it's not a disaster by any means. Zinc. Now we're moving into the DTPA extract for the micros. Zinc at 20.47 is high. You've got plenty of plant available zinc. We don't recommend zinc on anything till it falls below 1 part per million. Iron 22.6. That's we've had plenty of plant available iron there. Manganese, same story. We don't recommend manganese on anything until it falls below 3 parts per million. And copper is in the very high category. Not problematic, but you have plenty of copper there, and copper's taken up in such minute amounts by plants that you'll probably never run out of copper in this soil in 10 lifetimes. So then calcium, 1662, plenty of plant available. Calcium tracks in most parts of the country with the soil pH, and this is about the calcium level I expect to see with a pH of 7.1. Magnesium, plenty of plant available at 245, not a problem there. Sodium's low at 19. That's the one we don't want to see too high, and so that's good. We got, all in all, other than maybe just a little bit of low potassium, plant available nutrients, we're in really great shape with this particular sample. Excuse me. So then we'll go down, and I'm going to go down below soil health there on the right side. I'll talk about water stable aggregates. This is 23. David, can you scroll down a little bit, because the next page has the cation exchange capacity. Yeah, this is 10.7. So this isn't exactly what I'd call a heavy clay soil. And so this also tells me that this particular piece has had quite a bit of tillage, because there's really not a lot of soil structure there. Am I correct in saying that?
Yes,
That
you
you
are.
know?
Yeah,
Yes.
and it's been bare soil. I mean, this is my first year officially engaged in it, but last year I did kind of go by a few times, and it was your typical straight rows, tilled, and even when starting this year and talking with people, our there was a couple of people saying make sure you keep the rows straight and wide enough that we can get a tiller through there or a plow through there.
Mm-hmm.
Mhm.
Yeah.
So that was the
Yep.
default
Yeah.
concept.
Yeah. So, hence the reason why the biology is low. It's been pretty well destroyed over the years. The biology's been killed off, and then what was still living, the habitat was destroyed. So, yeah, they've had a pretty tough time of it. Okay, you can scroll back up or back down. Yeah, go back up to the above there. There we go. So anyway, the water stable aggregate's 23%. That's pretty low. Um, and so, just like everything else, it shows we've got room for improvement here. And then the soil health calculation at 6.41, that's low, but basically that's your baseline. That's
Mhm.
where we're starting. As you move forward, and you start, if we can minimize the tillage, start involving cover crops, after the cash crop is taken off, you'll see that number go up over time. Now, I'll go back and tell you what I was starting to tell you that I have in my presentation, why I don't always use the soil health calculation to track progress so much. I had a soil this last fall that came in from Tennessee, and it was a rangeland. It was a pasture situation. And I had a CO2 respiration of 500 and some parts per million, really incredibly high. the carbon, the organic carbon was only like 150. And so the percent microbial active carbon that remember I talked about a little bit ago, that it tells me whether we have enough food or not, it was like 400%. And then also on the nutrient side, we were very deficient on phosphorus and potassium. So the soil health calculation, because it had such a high CO2 respiration, it was like 30, which normally that's a score everybody dreams about having. But like I was showing Ray Ward this, and I said, I don't know that I'd necessarily call this a healthy soil, because we're short on carbon, we're short on a couple of the major nutrients, and so that's why I say that calculation can be misleading. I can track progress over time. If you do this plot again in 2 years from now, after you've been doing some cover cropping, maybe perhaps, and things like that, and trying to minimize the disturbance to the soil, you'll see that CO2 respiration at the same time of year go up. You're going to see the organic carbon go up, and you should see that water stable aggregate percentage go up too. So you can look at those three things and kind of see your improvement, over time.
Well, and then you just said something that I was kind of bouncing around in my head is I seem to remember from my days on the farm and stuff that we tried to do our soil samples at the same time every year because you really, from my understanding, you really can't compare, say, a September sample and a June sample as an extreme. So
Correct.
not saying that there may not be some benefit to doing multiple samples a year, but you need to compare January to January, June to June, September to September. Am I correct?
Yeah, that's correct. On biological testing, we tell everybody, try to do it year over year at kind of roughly the same time of year. Now, this one looks to me like you must have pulled this in early February. This sample.
I pulled it about 2 days before I sent it in. I
Okay,
pulled
so
it and
about the
sent it.
18th. What was the soil? Was it warm there where you were, or was it had been fairly cold?
Cool and moist. I had pulled samples about a week before that, and it was very, very wet, and I was afraid that it would be artificially anaerobic or something. So I
No.
waited till it dried up a little bit and did fresh samples so that I could send them immediately to you.
Yeah. Well,
And
that's
it
one
was with a
reason.
regular probe. It wasn't with a spade or anything, but your
Right.
regular,
Yeah.
tubular.
Right. That's one reason why our soil respiration is probably where it's at. The microbes really don't become active until the soil temperature, the average daily soil temp at about 3 to 4 inches, gets up around 50 degrees and then above.
Yeah.
So if you did nothing here as the growing season starts, once you get a good rain and it's been in the 80s every day for a couple of weeks, you could go out on this. That soil respiration would look different because those microbes would be a lot more active. How we measure this on soil respiration, I'll just go over that real quick, and so then I can make the point I'm trying to make. What we do is we measure out 40 grams of dried and ground soil, and we put that in a little kind of pill cup, plastic pill cup, and then we drop it into a mason jar. That little pill cup has 3 holes on the bottom of it. We then put 20 milliliters of deionized water in the mason jar, and then we seal it up with a airtight cap. As that soil becomes wet, it'll soak up through those holes in the bottom, and then it re-wets that soil, just like getting a rain on a really dry soil outside, and then you got an inch of rain on it. This does the same thing. Those microbes come back to life. And so they're like you and I. They breathe in oxygen, they breathe out carbon dioxide. We incubate this in an incubator at 75 degrees for 24 hours. And then there's nipples on the top of the cap that we plug 2 tubes into. And then we have a CO2 analyzer that will read the parts per million of CO2 in that jar. And, like I said, the larger the number, the better. So it's the same thing. When you took that soil sample, it was wet, and so we had moisture, but we didn't have the warmth for the microbes to be active. And I'm convinced after looking at these for the last 6.5 years that I think when the soil is colder like that, I don't think we wake up all the microbes that are in that sample. I don't know what percentage doesn't get awake. I don't have that, but I think it's not as good. So if we're going to do this in another year, I would recommend probably doing this either in the fall before it gets cold or do it in the spring around April.
Mm-hmm.
You know, and you're further south than we are. You're going to warm up quicker. You know, and so that would be maybe a recommendation I would make for you in the future.
Right.
So anyway, that pretty much covers it. Scroll down, if you would scroll down to that second page, and then there's not much on there, but oop, go back
Well, the
up.
second page of the first one.
Yeah,
Okay.
and this just shows that here's the cation exchange capacity, sum of cations, and then the percentage of base saturation. I can tell a lot by what the soil texture is by looking at the sum of cations because a clay soil has a lot more surface area to hold nutrients
Mm-hmm.
or cations, potassium, calcium, magnesium, sodium, hydrogen, than what a sandy soil is. And so this 10.7, this is probably what I'd call a sandy loam soil. Does that sound kind of correct from what you see?
Yeah, I mean, I haven't done a jar test and I haven't, like sent it through the extension office or anything to get a formal one, but I mean, it's when it's dry, it can be very crumbly, but when it's wet, it can be really sticky. So I haven't done, you know, if some of the other gardeners that are going to be doing this garden want to go out there at some point, and if they haven't, then I'd be more than happy for us to do some of those texture type
Mm-hmm.
ones in the jar test to evaluate that and stuff like that.
Right.
So
Well, and what I was going to say is clay particles can have a lot more surface area than a sand or a silt. Silt's kind of in between clay and sand, but and so that's why the higher that sum of cations, the more clay is in that soil because that's the holding capacity, a sense. And of course, base saturation percentages, that's the percentages of those nutrients that are on those particles. Um, we don't necessarily look at base saturation a lot. If I see a high sodium number, I want to look and see what percentage that sodium is occupying on that exchange complex. Hydrogen, if you had a real low pH, that's when you're going to start seeing hydrogen show up. And so, and that's the reason people will apply lime or calcium carbonate to their soils, is because the calcium will push that hydrogen off the exchange complex, and that's what raises the pH, if that makes sense. So anyway, that's pretty much takes care of kind of the nuts and bolts of what this test is.
yeah, because now these two plots are probably going to be treated rather differently this year. Not only is 1A going to be where we're doing our actual, gardening effort, B and C, which I did not send one in for C, they've already got a four-way cover crop I put out there. It may be a little bit early for some of them, but it is field pea, vetch, oats, and then I had a pretty good amount of daikon radish.
Okay.
So went ahead through some, good amount of daikon radish. And then, unfortunately, it's hand broadcast. I didn't have a no-till planter or anything to do a little cover, but I put it immediately before one rain. It had one day without rain, then it got another light rain. So I'm hoping something will come up, and then I got to figure out how I'm going to terminate it. But anyway, B is going to be essentially cover cropped and terminated, probably mechanically terminated. And A is going to be actively gardened. Now I don't plan on tilling it, obviously. However, I do have a rotary plow for my BCS or my Grillo that I plan on going out there and forming. We're either going to have permanent raised beds without like wood sides or whatever,
Mm-hmm.
or we may have some with sides. Somebody's donating or donating time and helping sponsor some wood to do some beds for lettuce and leafy greens and stuff. So
Sure.
there may
Sure.
be a substantial amount of disturbance this year, but after that, hopefully not.
Yeah. And I'll tell you, I am on, this will be my 5th season of doing a no till, no dig garden. After I started working here, I farm. I guess I didn't even talk about my background. I was a farmer here at Kearney for 34 years.
Hmm.
Um, I was I was one of the original customers of Ward Laboratories when it opened in 1983. I came out of college and came home to the farm in '83, um, and so now my garden is kind of my farm.
Hmm.
And after being around the soil health deal when I started here the first year, I thought, okay, I probably should practice what I preach. So I started researching, and yeah, no-till gardening is the thing. And what I noticed in my fourth year last year, I think the biology is starting to really ramp up in that garden now, where I haven't disturbed it. Because man, my garden just completely blew up last year. It was the best garden I'd ever had in my life. And I didn't hardly add any fertilizer to it.
Yeah, and I mean, one of
And
the big differences for people, whatever label, whatever system technique, no-till, lasagna, permaculture, or whatever it is, I think one of the big differences to what is now considered conventional, whether it's farming or gardening, is these are slow results, not fast results.
yes,
This
they
is
are.
not buy a bag of results and put it
hmm
out. So,
I get people call in and they've run a soil health assessment and they think it's the magic bullet that they're going to do something that first year and it's just going to change everything. No, that does not work. It does not work that way. It's a very slow process. What I tell people, when you start non-disturbing, diversifying cropping rotations, which it's easy to do with a garden situation. I
mhm,
move my different plant types around every year, um, and and then involve cover crops in the mix. So you've got a living root in the soil as much as possible, putting root exits down or carbon,
mhm.
essentially feeding the microbes. Um, you'll see, and honestly, David, I wouldn't even recommend you necessarily to do a soil assessment next year. You're probably not going to see any change at all. In year three is when you start to see things change a little bit. Year five is when the system starts really starting to fire, and I'm kind of on year four, but I'm also one of my paddocks is on the edge of the old 4-H calf pen, so I've got plenty of fertility there and more organic matter because of manure
Yeah.
over the years. But yeah, it takes time. You're correct, totally correct in saying that. It doesn't happen overnight.
Karen?
It very interesting. I'm thinking about my own garden now.
Well, I've got like 5 different paddocks in mine, and I've got a small lasagna garden raised bed also. And so I did we've been in the 70s here a little bit in the last two or three couple of weeks. And one of those days I got the piece of paper out and made my map and figured out my rotation where I'm moving stuff to this year. So yeah, spring is coming and I'm ready for it. I know
And I
that.
mean, I'm trying to go in multiple directions with this as well. Like me, it was raining yesterday, and I went out during the rain, which is something I tend to do because I like to see where the water's going. Is there water
hmm
flowing, surface water flowing? Because I want to know I mean, you can usually tell the path anyway if you're used to looking at it, but I want to see the water. But while I was out there were actually some brassicas which had already bolted and starting to flower, and there were a bunch of little flies on it. And then I noticed the flies weren't moving
hmm
and got to look at them, and they appeared to be syrphid flies, which are pollinators, but they're also good predators, or at least their larvae are.
hmm
So luckily, we've got a good university here. I'm second generation, I can't see it, mascot ASU. Um, and I reached out to the department chair, who's an entomologist, just to confirm that it is a syrphid fly and what probably killed it. It's been very moist and raining, so she said it looked like fungus. Don't worry too much about it. But it was good to see that where there was some habitat, there was some pollinator predator already there,
hmm
waiting for aphids or whatever if that happens. But I'm
To
trying
your
to attack the health. I'm trying to attack the soil. I'm trying to attack the pollinator predator habitat and sequential nectaring, and just trying to bring all this in without doing too much so that I don't overwhelm those who may not be used to it.
Right. I try to get my hands on some pollinator mix. Usually every year at conferences, I can get my hands on little packets that different organizations will have out on their tables, and so I'll always plant a little area on the edge of my garden, with that. And so that way I've got some habitat for the pollinators.
Yeah.
2 years ago, I had green cover seed. I had some of their milpa garden seed. So you've got like, I don't know what there is. There's 50 different things,
Yeah.
seeds in there. And I had one little area that I wasn't going to grow anything in. So I put that in there. It wasn't very big, but my Lord, that stuff came up and, excuse me, later in the summer, I mean, I'd go out there and that thing was just buzzing. It was just alive with insect life, and I thought, yeah, this is pretty cool, you
Yeah.
know. And of course, I know the advantages of having beneficial insects because I farmed for so long. Ladybugs being in a cornfield, that's
Mhm.
desirable. And when I was a little kid, the insecticide they'd use on the cornfields, for corn borer or what have you, the bad insects. The problem was it always killed the ladybugs too.
Yeah.
And so yeah, now a lot of the herbicides they use in corn, and they don't use as much, or not herbicide, insecticide, and not as near as much is used anymore as there was 30, 40 years ago. But yeah, it also is formulated so it doesn't kill the beneficials, and so that's good too, because yeah, they're definitely of value. That's for sure.
Well, I don't want to take too much of your time. I'm sure it's a busy day and it's a Friday, so you may already be looking at that clock a little bit.
Well, it's been a long week. I was down in Liberal, Kansas for a conference on Monday, and which is 5 hour drive, and then since I came back Tuesday morning, it's been busy this week. We've got a lot going on, and we're starting to get a lot of soil in now. I mean, it's been pretty nice up here in the Midwest where we're at for really the last month. We did get 3 inches of snow overnight last night, so that'll slow up the soil
Oh,
samples
wow.
a little bit. Yeah. And the nice thing is these March snows up here, they're always wet, heavy snows, and they'll melt. I think we're going to be in the 40s tomorrow and in the 60s on Sunday, so this will all get melted, and I like snow because it soaks in slowly. It does. It's not like getting 3 inches of rain in an hour.
Let me ask you this. This since a couple of the conversation we had and some of the other reading I was doing, and I may be totally off on this. I've always heard that after a storm, especially a lightning storm, that the lightning creates nitrogen or puts nitrogen in the soil. But the way this test, your soil health assessment test is done, or doing the carbon dioxide, um, is it possible? But some of that is just you had dry soil, you got a rain on it, so the life wakes up, and that just starts that cycle, the carbon and nitrogen cycle going, and the results that we see of the plants greening up and all of that, partially, if not probably not completely, but partially, is a result of that process rather than lightning somehow putting nitrogen in the soil.
Yeah, yeah. Yeah, I don't know that there's a lot of scientific data to back that up about lightning. I've heard that before.
Yeah.
I mean, we know our atmosphere is 78% nitrogen, but um, yeah, I don't know about that. Well,
I mean, it's
it,
just another one of those things that just cause two things tend to occur. You
yeah,
tend to have a storm and then you have a greening up of the plant matter doesn't necessarily isn't causal. It's just, it
well,
correlates, but it's not causal necessarily.
and I'll say this, our organic nitrogen measurement, I mean, that's organic. Of course, it's not plant available, but like what we show on that, like the organic, scroll back down because I didn't talk about that much. Go back to yeah. Okay, so see down at the bottom on the left, the organic nitrogen release, parts per million.
Mhm.
Okay, so that's 9.4. Now, the depth of this sample was 8 inches, so that equates to about 24 pounds per acre of organic nitrogen that will be released by the microbes. Now, the microbes have to consume the nitrogen and they have to die, then the nitrogen becomes plant available. That's not going to change regardless of a rainfall. But what happens there is when you get a rainfall and it's kind of warm, it's not cold, um, and the soil's dry and it gets a rain, those microbes wake up just like you say, and what do? They start cycling nitrogen. I mean, they're eating carbon, but they also have to consume. They have to have a 24 to 1 carbon to nitrogen ratio. So you'll see a flush of activity, and then that releases a lot of nitrogen. And I've noticed ever since I was a little kid, when we'd get a rain, and this would be, we have irrigation up here, so this would be earlier before we started irrigating. It seemed like the corn would really grow right after the rain. Well, I found out that's the reason, because the biology got woke up, it became active, it was cycling a lot of nitrogen, and that made it a plant available to the plants. And of course, that inspired the growth, the added growth. That makes sense?
Yeah, I mean, that was just a question that had been rattling around in my head for a little while, and as much room as there is, it's starting to hurt. So I thought I'd ask it.
Well, and I'll tell you, I'm not saying that's wrong. We're learning in the soil
Right.
health world, regenerative agriculture world, we're learning new things all the time. Um, we are meeting, we've been meeting for the last 4 months with a couple, three of the more prominent players in the regenerative ag movement. And then we brought in a new scientist with us today on this Zoom meeting. We're trying to figure out a way to measure the water vapor that the microbes give off. We know there's some, we're trying to figure out how to measure it. But now, today, this new scientist, we started talking about biofilm in the soil.
Okay.
And this is moisture, but it's not necessarily subject to evaporation and all that.
That's making me think of the water harvesting class I took with
Mm-hmm.
Dr. Peter Coombs down in Australia about the biofilms actually being part of what cleans the water, and it's desirable. Whereas a lot of people do their water tanks and once a year they clean them out or they chlorinate the crap out of them and kill everything. Well, you've just eliminated, from what his research is, one of the primary filtering agents, active filtering agents
Mm-hmm.
of the water column.
Well, it's the soil aggregates that do the
Yeah.
filtering, and when you till it, you destroy the aggregates.
Yeah.
So yeah, it's and the biofilm, that was kind of new to me today, and I thought it was fascinating. And I don't know if we still know what we're going to measure, but it added a whole new twist to the conversation we've been having. So
Just what you needed, more rabbit holes.
well, that's like Jimmy Emmons is kind of the one that he and I got this thing started because we were at a conference and talking to each other. And we're I kind of told Jimmy this meeting, I'd like to figure out if we're going to measure something, let's kind of figure it out. And I don't think we accomplished that. I think maybe we have a direction we're thinking now. But it's fascinating to get together with this group. Dr. James White at Rutgers is one of them too. And if you've ever seen James speak, he's pretty fascinating, the work he's been doing in the microbiome and everything. And so, yeah, it's a fun learning experience every time. So, well, very good.
Well, I
Any more
appreciate your
questions?
time. I don't have any more unless Karen does. And like I said, I don't want to take up too much of your time. I really, really appreciate this opportunity.
I appreciate the time to explain our soil health assessment. And Karen,
I did
David,
have one question.
sure.
Um, can we send soil samples of raised beds to have
Absolutely.
this?
Absolutely.
Yeah, because I know the University of Arkansas, their testing facility, if it's got very much organic matter, mulches, things like that, their equipment is not set up for that. They will not accept it. Or if it makes it through, they have to go through and reclean. Because the last time I used them, I actually hand delivered it because I wanted to see the lab. I wanted that educational opportunity to actually go through the lab. And then for the organic material testing, they don't do it at the main lab. They have to send it up to Fayetteville, which is an additional cost and rigmarole to get all that done. So it is very much geared to agricultural, massively tilled soil down there.
Yeah. Well, and the thing about university labs, they're not very big. They don't all have the necessary instrumentation. Staffing, a lot of it's students, and so they just don't have the staffing. And they do testing for the general public, but you might send them a soil test, and you might not see the results for 2 months. And whereas we turn a soil sample, generally 3 days from the time it hits our doorstep, we're sending results back. That's
Oh,
Now,
wow.
for those of us in Arkansas, one big difference is we can send, as a homeowner, we can send one test to the university free every year.
Right.
Ward is obviously not a university. They are a for-profit corporation. So there is a fee or fees depending on which test or test that you want and per sample. So
Well,
you can go on their website, you can tell, how many, because this is what I did, how many samples you want, and they can actually send you, you pay for it up front, and then they'll send you the box or the bag or whatever, and some of that kind of material, which I understand I could probably also just put it in a clean Ziploc or clean
yeah.
other container and send it along with the printed off sheet of what the test is, how the depth and all that information, which is all on the website. But just if somebody that's watching this later wanted to do this, just understand it's not the university. You're not going to get one for free, a year or something of that
Right.
nature.
Right.
And it's a different test for, for looking for different things.
Well, and within the soil health assessment, the regular nutrient measurements is pretty much our soil routine test. It's a $23.65 so test. So it's not astronomical
Right.
by any means, for producers, ag producers, we don't recommend any more than 40 acres per sample. Well, you're a shade over 50 cents an acre for the soil test, and you know, and if you can save applying some nutrient, you're going to capture that cost rapidly. So,
Well, we've been trying to do no-till. This will be the second year. And so come April, I think I'll be sending in a test.
all right. Well, very good. Well, thank you. Yep, we'll be looking forward to it. And yeah, thank you again, David, and thank you for doing business with Ward Laboratories. And yeah, let me know if I can help you out in any way.
Very good, sir. I really appreciate it.
All right, take care.